Hi friends, a very good evening and thank you for joining in. So could you please confirm in the chat window if you are able to hear me and see my screen, if it is clear or not? So could you please confirm that so that we know that there are no technical glitches and we can get started with the problem solving session itself. So I see a few questions here. Okay, all clear. Okay, that's good. That's good. That's good. So we'll wait for a minute or so, and then we'll get started with the session itself. Right. So this is about digital logic new lectures that we are uploading. We're still uploading them. From tomorrow, you'll get roughly like 2 hours of content added every day. Right. So DLD, we have some content already, new content that we have already published and overwritten the old content, but we'll be pushing out roughly 2 hours of content every day starting tomorrow. It's getting processed now, right? So next thing is, will GATE 2021 exam be postponed? Most likely no, because I think that by the time our turn comes for the GATE exam, they would have figured out how to conduct exams at scale with low risk, because they would have conducted a lot of national level exams like IIT, JEE, and I'm sure various government organizations will figure out how to conduct these exams safely by February. So most likely they may not get, again, we don't know. Most likely they would still conduct it in February, but we'll have to wait for the official announcement. Okay. So somebody says, this is a question from Sudarshan. He says, I have prepared GATE on my own. I'm a non-CSC student and I've cleared GATE but not with such a good rank. What would you recommend? Taking the course or taking the test series and revision? My suggestion is, if your conceptual clarity is there, if you have good conceptual clarity, if you already know all the concepts, you don't have any conceptual gaps, you can just follow our publicly available notes, because that's a great way for you to revise. Number one, solve as many problems as possible. But because remember, learning the concepts is only 1/3. 2/3 of it is practice. So if your conceptual strength is good, but if you're lacking primarily on problem solving, there is no point taking the whole course again. Again, you will have to evaluate it yourself. If it's just about practice, take a test series which might help you. Also try to solve as many problems in public forums as possible, right? That's what we would recommend. Again, you can call us and talk to some of the folks in our teams who can guide you much more closely based on where you stand, right? Okay, sounds good. So let's get started with the mathematics session. So a quick overview. So this is based on a slide that we prepared last year. This is for all the question papers from 2014 to 2019 GATE. This is a distribution of marks across these topics, right? If you notice, whole of predicate and propositional logic, on an average you get about 2 marks. There are some years where you get 1 mark, there are some years where you get 4 marks also, but on an average you'll get about 2 marks. Set theory and algebraic structures, whether it is lattices, groups, etc., it's about, on an average, about 3 marks. Graph theory about 1.5 marks, roughly. Combinatorics, probability, calculus and linear algebra, right? Overall, the average number of marks are about 14 to 15 on an average, right? Today, this is the syllabus that we shared with you. It is sets, relations, functions, lattices, groups, graphs, propositional and predicate logic. Again, since this is the first iteration that we are solving these interactive problem session, we would try to cover easy and medium problems now, right? But as we progress through it, as we come closer to the examination, we'll focus more on medium and hard questions. Since this is the first session, again, as we mentioned earlier, we'll go through each of these topics, each of these subjects and each of these topics in a cyclical fashion. This is the first iteration. That's why we are doing only easy and medium problems now, but we'll be moving to medium and hard problems in the next iteration and as we come closer to the examination, right? So let's go to the first question, right? Here comes the first question. Again, we've also started tagging if the question is easy or medium. Again, this easy or medium is based on GATE standard, not our own imposed standard. It is just GATE standard, right? So please take some time. Again, rather than speed, please try to focus on accuracy. Try to get your answer, post your answers in the chat window. Once it is over, I'll also explain the solution for each problem. Once enough number of students answer, I'll go there. I'll go and explain the solution, okay? Just like the way we have been doing for the last few weeks. Again, our mentors also have joined the chat window. They'll try to answer some of the questions that I may not be able to answer because we have to go with the flow and cover the 10 questions in 1 hour. Again, while by gate standard this is a medium problem, this is actually an easy problem. Please focus on accuracy at this point rather than on speed. Okay, I see a few of you putting in your answers. This is a 60 to 75 minute session. So we'll solve about 10 problems in an interactive fashion, and once some students answer the questions, I'll also explain the solution itself. Okay, I see a bunch of answers, so let's just wait for a few seconds and then we'll go into the solution itself, right? Let's wait for a few seconds and then we'll go into it. Okay, so let's get into this answer. Before we get into it, there is a question by, I think her name is Shivangi Agarwal, who said, could you cover some of the topics in live sessions which are difficult to understand? Shivangi, any concept that you have a problem understanding, please reach out to us if you're a course registered student. Our team will help you understand it better. And again, if there is a specific doubt, please do ask us. If it's a specific doubt, we'll give a specific answer. But if it is broadly about a concept, don't hesitate reaching out to us over email. And if something cannot be resolved over email, feel free to call us. One of our mentors will help you with it, right? We're also planning to conduct some topic discussions based on questions that students often ask. We will do that, but they most likely will be private sessions that we'll do once we finish the practice of all subjects once. Okay, sounds good. So, okay, where is this? Okay, let's look at this question. This question says fx equals to this, and you're given a bunch of options. These three options are about f inverse. This is about f of f, right? So let's just think, because there are some options about f inverse, let's think about f inverse also, right? So if f of x equals to y, then you can write y equals to 3x plus 2 by 5x minus 3, right? If this is the case, if you want to compute f inverse of x, you basically need to compute, basically represent x in terms of y here, right? That's what you have to do, right? So with some simple modification of this, let's assume I pull this that side. This becomes 5xy minus 3y equals to 3x plus 2. And what can we do now? Okay, so let's pull this to the other side. Let's pull this side. So you get minus 3y minus 2. So this is here. I'm getting this side. Let's pull that side. So equals to, you take x out because we want to get x in terms of y now, right? So that's how you can compute inverses, right? So you have 3 here. So you have 3 minus 5y, right? Because we'll pull this 5y that side. So now if you notice, you can easily get an expression for x in terms of y's, right? So what is x now? X is nothing but minus 3y minus 2 by 3 minus 5y. And if you multiply both numerator and denominator with minus 1, you get x equals to 3y plus 2 by 5y minus 3, right? So what is this? This is nothing but f of y. Right, so or let's not call it f of y, let's call it g of y, because it's okay. So let's call it g of y. Now if you notice, this form of the function and this form of the function are exactly the same, except that we replaced x with y, right? So f of x is same as the f inverse of x, right? So if you notice, again this whole process is primarily to compute f inverse of x. They both are exactly in the same form. So obviously if you look at it, option A strikes out. Right? Again, you can check if option C is incorrect, but again, since many options are with f inverse, you just compute the inverse of the function and you're done. This is actually easy, but we tagged it medium because this is the average hardness of problems that you encounter in GATE, right? For this topic, right? So very simple, straightforward question. Okay, cool. Let's go to the next question. Okay, this is an easy question. Again, since this is the first iteration of this subject, we are asking easy and medium questions. In the next iterations, we'll increase the hardness. We'll have more medium and hard questions. There is no point doing too hard questions for GATE preparation. It's a very simple question. That's why we tagged it easy. Again, you sometimes get questions like this for 1 mark in GATE. Okay, I see a wide set of answers. Again, folks, please look at your answer and recheck it, because maybe there is something that you have missed. This is a fairly straightforward question. Since many of you have put in your answers, let's go into the solution itself. So what does it say? It says x is related to y. Again, this is one way of writing it. This is also another way of writing it, right? Word x is related to word y if x and y have at least one letter in common, right? So we have reflexive, symmetric, transitive, right? So we all know what is reflexive, right? Reflexive basically means x is related to x itself. You just need to know the definitions here. What is symmetric? If x is related to y, then y is related to x. What is transitive? Transitive means if x is related to y and y is related to z, then x is related to z. Right? These are the definitions. Right? These are definitions of these relations. Now look at it. If you have two words, look at this. A word will always be related to itself, because a word will have all the characters same as the same word itself, right? So it just needs to have at least one letter in common. So obviously this is reflexive for sure. What about symmetric? Imagine if you have two words. If you have word like cat, right, and if you have another word like let's say DAG, okay, directed acyclic graphs. Okay, it's not a word, it's an abbreviation, but let's just take them. They both have one character A common. So if x is related to y, then y is also related to y is also related to x, right? So this relation is also symmetric, common sense. But transitivity is what is important that we have to check, right? So for example, imagine if x equals to and, I'm just constructing an example here, right? And let's say y equals to next. Do both of them have a common character? Yes, they do, because there is n here, there is n here. So you can say x is related to y. You can say that. Now let's take another word z. Okay, let's say this is HER, right? If you notice now, there is E here, there is also E here. So you can say y is related to z. So I'm just constructing an example where x is related to y, y is related to z, but is x related to z? Is there a common character between x and z? AHNEDR? No. So x is not related to z. So this relation is not transitive because we constructed a very simple counterexample for this, right? So this relation is reflexive, common sense, it is symmetric, trivial to argue. It is not transitive because we constructed an example for it. So statement A, I think, is correct, right? Reflexive, symmetric, and not transitive. So option A is the right option here, right? To solve this problem, all you need to know is simple definitions of these terms and be able to construct a counterexample here. Again, please understand that most of discrete and engineering mathematics, all you need to know is the terminology. You need to know what the terminology means, what the rigorous mathematical definitions of things are, and you need to know properties of things. If you know properties of, let's assume we're talking about abelian groups or we're talking about lattices. If you know some basic properties and basic terminology, gate is fairly straightforward to solve. Both of these are important. We'll see some applications of where you need properties, especially with group theory, once we go a little ahead, right? So it's fairly straightforward. Okay, cool. So let's go into the third problem now. Yeah. This is also a medium question, which means this is the average type of question that you can expect in GATE. So this is also a simple question. You just have to apply basic properties of order of an element. That's it. This is a fill in the blank type, right? There are no options, so please fill in the numerical value that you have to fill in the blank. Just recall what is the definition of order of an element. Okay, I see a couple of answers, different answers, but certainly things that students have put in. So let's wait for others to also put in their solutions, then we'll go into the solution itself. Okay, people have put in answers like 1, 10, 20, so all sorts of numbers. So just rethink if your answer is correct or not. Again, this question was set based on some assignment problems and final exam questions at some of the IITs. It's based on that, it's not exactly the same problem. Okay, so I've seen a bunch of answers, so let's go into the solution itself, right? So it says G is a cyclic group and X is an element of G, and it says let the absolute value of X represent the order of the element X, and we are given the order of this element X is 20. What does the order of element equals to 20 mean? It means X power 20 equals to the identity element in this group. That's what it means, right? Then what does it say? It says what is the order of X power 11, right? So all you have to find out here is take X power 11 power some K equals to E, right? Again, E is the identity element of the group, right? So all we have to do here is we have to find this K. This K is nothing but our solution here. We just have to find this K, right? Now if you think about it, we know that X power 20 equals to E, and E into E is E itself, right? So if you think about it, if K equals to 1, what do we have? We have X power 11, right? Of course, X power 20 is E, X power 11 is not E. So if you take K equals to 2, what do you get? You get X power 22, right? What is X power 22? X power 20 is E into X square. So X power 22 is nothing but X squared, right? So similarly, if K equals to 3, you will get X power 33. Right, X power 33 is nothing but X power 20 into X power 13. So X power 20 is E into X power 13, so you will get X power 13. So if you keep going, at some place this has to become E, right? So if you keep, this is 11 into 1, 11 into 2, 11 into 3, so on and so forth. If you notice 20 and 11, right? If you notice, do they have any common factors that divide both these numbers? No. So you have to keep going on till the time you have X power 11 into 20. If you notice, if you keep doing this, X power 11 into 20 is nothing but X power 20. Look at this, it is nothing but X power, this is X power 220, right? So this is nothing but X power 220. Now if you notice X power 220, it is nothing but X power 20 power 11. We know X power 20 is E. So E power 11 we know is E, because E multiplied by E itself any number of times is E. Okay, because there are no common factors for 20 and 11, right? There are no common factors. So you have to go through all of this, and now we know that X power 220, or in other words, X power 11 power 20, right? X power 11 power 20 is E, which means, and look at this, it is the smallest such exponent, right? Because if you keep going through this process, this is the first exponent, this is the first case where you will encounter X power 11 power some K equals to E. So this is, again, from the simple definition of what is an order of an element, this 20 becomes your K. So the answer here is nothing but 20. That's it. Again, this question was based on a very interesting assignment problem at some of the IITs, and the question is as follows. Imagine you have a cyclic group, and let's say you have an element A whose order equals to n. This is actually a very interesting property. You can go to Wikipedia and see this property also. So in many IITs, either in assignment or in end semester exam for their BTech programs, this is something that they ask you to prove. Okay, so you have order of element A. Again, remember that A is an element of the cyclic group, and order of this element A is n. Then you can show that the order of A power r is equal to n by GCD of n comma r. This is a very interesting property. Again, even if you don't know this property, again, we have taken this from, we have actually constructed this example based on this type of assignment problem that we have seen in some IITs. So they ask you to prove this. So they ask you to prove this as part of the assignment or the examination. So this, if you don't know this also, you can solve it. We solved it without knowing this property. If you knew it, it's much faster. But we learned how to, again, now, given that we figured out this whole solution without knowing this property, I think some of you can go ahead and even prove this very easily, right? Again, proofs are not required for GATE, but proofs do help you strengthen your core conceptual stuff, conceptual understanding. Okay, so cool. This is an easy problem or medium problem by GATE standard. Sorry. Okay, so let's go to this. Again, this is slightly lengthy because you have to think of some nice examples here, but it is not hard. So think about it a little. It is not hard. It's slightly lengthy because you have to think about both the statements S1 and S2. Sorry. Again, just think of basic definitions, right? Because there are so many concepts in discrete and engineering mathematics, it's very common to forget some concepts. Okay, I see A, B, C, all three options. So let's see. Okay, some of you have put in your answers, but there is a wide spectrum of answers here. So please rethink about your answers once. Actually, these types of questions where you have two statements and you have to think about those statements are slightly time taking because you can't mess up any one of them and you have to think critically about both the statements. Okay, so some of you have put in your answer. So let's go through each of these cases, right? So, okay, you're given two statements. The first statement is about Eulerian circuits. The second one is about vertex connectivity. So let's go through both of them one by one. Okay, so what does this say? This says if G is a Eulerian graph and there are two edges E and F in G sharing a vertex, then G has a Eulerian circuit in which E and F appear consecutively. Okay, so this is either true or false, right? If it is true, you have to convince yourself that it is true, right? If it is false, you have to construct a counter example, right? So again, this is while people say gate doesn't have proofs, you have to convince. You don't have to write the rigorous mathematical proof, but you have to convince yourself whether the statement is true or not. Similarly, here also, this is saying something about the number of edges, right? It's saying about some number of edges given some vertex connectivity K and all of that stuff. Again, you don't have to prove it, but if you know how to think from a proof perspective, you can easily answer this. Okay, so let's look at this. So let's assume you have two vertices E and F in G sharing a vertex. Okay, so let's assume I have a vertex here. This is a vertex, and let's assume these two edges are E and F. Okay, so what does it say? It says, okay, then G has a Eulerian circuit. Okay, Eulerian circuit means you have to start at a given vertex, touch all the edges once and come back. All right, Eulerian circuit in which E and F appear consecutively. Okay, so let's see, let's construct this. So you have E and F. So there is, let's assume one more vertex here. You're creating a loop-like structure. Okay, so now what happens if you just have this? If you start at this vertex, or if you start at this vertex, E and F. Okay, let's say this edge is A. Let's just call some name. Okay, so you have a Eulerian circuit here. You have a Eulerian circuit. Suppose you start from this vertex, you go here, and you go here. So if the sequence of edges are E, F, A, right, then obviously E and F appear consecutively. Simple. Okay, seems logical. But now can you modify this graph so as to make that statement incorrect? Right? Is that possible even? Let's try to do that. I mean, that's important part of proofs. That's how we have to think about proofs. Can I first try to disprove something, or can I use existing properties that I know to prove it? Okay, that's how most proofs work, right? So here we have one cycle here. What if I have another cycle like this? What if I have a structure like this? Let's just say, so this is A, let's call this B, let's call this C, and let's call this D, right? So let's say these are, let's assume this is how my graph looks like. Again, E and F have a common vertex, that we know for sure. Now in this structure, look at this, in this structure, if I'm constructing a, okay, let me change the color slightly. Okay, if I'm constructing a Eulerian circuit, suppose if I start from here, I can go here, right? I can go here, I can go here, I can go here, I can go here and come back here. So in this Eulerian circuit, look at this, in this Eulerian circuit, my E and F are not consecutive to each other. Between vertices E and F, between edges E and F, I have edge A also, right? So there is a possibility, at least from what we have seen till now, right? There is a possibility that they both are not consecutive to each other. But the question says, look at this, then G has a Eulerian circuit. Can it even have what we drew is one Eulerian circuit, right? Is there possibility of some Eulerian circuit here where E and F occur consecutively? Now remember, think about it logically enough. Again, this is all about the proof structure in your head, okay? So let's assume suppose you take E to come towards this side and you take F after that. Then you are already here. Now if you take A, again, if you take A, you can't process this part of the graph, right? Again, you can try, again, this is called a double looped graph, right? Because you have a loop-like structure here, you have a loop-like structure, okay? Or this is also called as a graph with two disjoint cycles which are joined only at one vertex. This is a very interesting graph, right? So again, you have to construct this counter example here. This proof is all about, this statement is all about constructing the counter example. Okay, this is one such nice example. Okay, so by this example, we can say that the graph G does not have a Eulerian circuit in which E and F appear consecutively, right? So this statement is incorrect, number one. Now let's look at the second statement. So what do we have? We have S1 equals to false. So S1 equals to false, this is true. S1 equals to false. Now you have to, so this is false, but what about S2 now? Again, you can actually rigorously prove this, right? How do you prove it? Very simply, or you can disprove this. For disproving, it's very simple. You just have to come up with a counter example, like the graph that we came up with. It's a very popular graph in computer networks actually, right? So on the other hand, let's look at S2. What does S2 tell us? S2 says we have a graph with n vertices and vertex connectivity equals to k. How do we represent vertex connectivity? We represent vertex connectivity by this. This is equals to k, right? What is the definition of vertex connectivity? Vertex connectivity basically means, I mean, there are many ways of thinking about it. One simple way to think about it is, it is the size of minimal vertex cut, right? This is one way of thinking about it. Again, this is how I think about it in my head. It is the size of the minimal vertex cut. Now, what does it say? It talks about number of edges. So we have this very simple property that we all know, right? So we all know this very simple property, which is that sum of degrees of vertices V in the whole graph is equal to twice the number of edges. We know this, right? So from this we can easily write that the number of edges equals to sum of degrees of each of the vertices by 2. Right? And we know that this has to be greater than equal to delta of G into n by 2. Again, by 2 I am keeping it the same. Again, what is delta of G? Delta of G is nothing but the min degree. Remember, this is nothing but the min degree. This is the min degree of your graph, right? Which means every vertex has at least these many edges, right? So this multiplied by n will always be less than the sum of the degrees of all the vertices. Now, one more very interesting thing here, one more very interesting property that you have to leverage here, very importantly, is this. If you have the minimal vertex cut or vertex connectivity as k of G, what is important here is that, okay, let me use a different color. Okay, so one important property here is the minimum degree of the graph is greater than equal to the vertex connectivity, which is nothing but k in our case, right? So remember that the vertex connectivity is k. Again, all these statements can also be trivially proved, right? If your vertex connectivity is k, then the minimum degree has to be greater than equal to this. So which means from this equation, I can write this as k into n by 2, right? Because we know the delta G is greater than equal to k, right? So from this whole equation, what do we get? We get that the number of edges is greater than equal to kn by 2, right? Very simple. What did we do in this problem? So from this statement, it's from this logic, it's very clear that this is incorrect, we saw this, and this is correct. Okay, very simple logic here. Again, you have to follow the steps. In this case, we built a counter example. Again, proving something wrong, the easiest way is to construct a counter example, and the counter example graph that we constructed is this type of graph. It's a double cycle type of graph, right? So for this, what did we do? To prove that this is correct, we just applied simple rules and simple equations from graph theory. Of course, you have to know, again, this property is something, if you don't know, you can easily arrive at it logically. Okay, from the definition of what is vertex connectivity and what is min degree of a graph. Again, this also is fairly trivial to prove, or fairly simple. I won't say trivial, but simple to prove. But we arrived at this by just using first principles very easily, right? So what is the answer here? Let's see, S1 is false and S2 is true. We have this option, so option B is the right option. Again, problems like this typically come for 2 marks, typically, and they are time taking, because constructing this counter example is not trivial, right? It's not trivial, to be honest with you. Okay, this is more easy. This is an easier thing to prove, to be honest with you. This is a slightly more tricky thing to prove because constructing the counter example is the hard part. Okay, sounds good. So let's go to the 5th problem. Again, I've spent little more time here because this is one of the good problems in this whole set. Okay, oh, this is okay. Again, please be very careful because propositional predicate logic, people make tons of mistakes. So please be very careful here. I can't emphasize how careful you should be. I know this whole topic, we spent so much time covering this in the course with lots of examples because we know people make mistakes here. I see A, B, C. I think except D, all 3 options I see here. Just try to translate these into English. That's one way to think about it. Try to think logically about these statements, then you'll crack it. This is actually easy, but we put it as medium because most students consider these types of problems as slightly harder. Okay, we also have option D now that somebody suggested. Again, folks, it's very, very common for people to make mistakes even on easy questions. That's perfectly okay. Don't worry about it. It's perfectly okay to make mistakes on easy questions at this point. I think we had this interactive session yesterday, right? So take your mistakes as opportunities to learn. Okay, so let's get into the solution here. I think, yeah. Rahul, that's a good question. S of x basically means that x is a sports car. F of x basically means x is a fast car. I'm sorry, we should have written it. My bad. Okay, my bad. I think my team wrote it. When I was preparing this, I think I messed it up. My bad. Okay, S of x, Sx basically means x is a sports car. F of x basically means x is a fast car. Sorry, I should have clarified that. Okay, so let's go into the solution, right? So let's think of these options and eliminate. So what does this say? Think about it from English. It says there exists some car x such that if x is a sports car, it is a fast car. That's what it says. It is not. What is our statement here? All sports cars are fast. That means there could be non-sports cars also which are fast. That's possible. But all sports cars have to be fast. But what is this saying? This is saying there exists some car x. Okay, let's say that car is some x. That car is a sports car. Okay, again, so there exists a car x such that if the car is a sports car, then it is a fast car. Right? Not necessary. There could be non-sports cars. Again, this is talking about some x. This is not talking about all sports cars. It says there exists some x. Okay, right away, by just looking at it carefully, you can eliminate this. Let's look at the second one. What does the second one say? It says for all x, right? X is a sports car and x is a fast car. Not always, right? Not always, because it could so happen that x is not a sports car but a fast car. Right? That could be a case. But this one doesn't capture that. So this is also not the right option. For this option, the way I would imagine this is, because you know this, right? Not of A or B is nothing but A, if A then B, right? Right? So I write it slightly differently. I write not A or B. This is how I write not, but this is also another way of writing not. Some people also write A dash as not. Multiple ways of writing the same thing. So this one, if you write it, it says for all x, which means for all x, S of x implies f of x. Now what does it, let's try to read this in English. It says for all cars, if x is a sports car, then it is a fast car. That's exactly what this is saying. This is saying all sports cars are fast. It doesn't say anything about non-sports cars. It doesn't say anything about all fast cars. It is only talking about sports cars. So what does this say? This says for all x, for all cars, if a car is a sports car, then it is a fast car. And it is true for all x which satisfy this. Right? So for all x it's saying this. So it says for all sports cars. So effectively what this is saying here is all sports cars are fast. So option C is the right option. Again, it's very common to mess up these types of questions, because the way the best way is try to read this in English. I mentioned this in the course videos also, that equations are the poetry of mathematics. Try to read it in English and try to see what you read here, does it logically match this statement or not. Again, if you're not comfortable in English, right, think about it in your mother tongue. Okay, translate this into your mother tongue. My mother tongue is Telugu, right? Because my mother tongue is Telugu, right? For somebody it could be Hindi, Malayalam, Konkani, whatever language, right? Translate this into your mother tongue, because if you're better thinking in terms of your mother tongue, translate this into your mother tongue. Now think, if your mother tongue is Hindi, think in Hindi or think in Telugu, right? That helps you a lot, because I used to do it when I was not very comfortable with English at some point in my life, right? Especially for solving problems like this. We have seen people, we have talked to some students who think in Hindi, and it works perfectly all right for them. Okay, so this is one approach. Okay, cool. Let's go to the next question. Okay, this is considered an easy question. This is, if you know what is a partial order, this is straightforward question, folks. Okay, I still see variability in answers. Again, as a hint, just draw the hash diagram. You draw the hash diagram carefully, you get your answer. Okay, I see a bunch of you have put in your answers. So let's go into the solution, right? You have this set. Let S be the partial order and set defined by A divides B. Okay, very simple. So look at this. If you look at these numbers, 2 and 3, right? They don't divide each other. So let's write 2 and 3. Then you have 4 and 6, right? So 4 is divisible by 2. If you take 6, 6 is divisible by 3. 6 is also divisible by 2, but 6 is not divisible by 4, right? So till now we have done till here. Next you have 8 and 12, right? So let's write this down. 8, this is divisible. 12, 4 divides 12, 6 also divides 12. This is called the hash diagram, right? If you just draw it carefully, you'll get it. Then you're done with 8 and 12, you have 16 and 24. So let's write it. 16 is divisible by 8, 16 is not divisible by 12. You have 24, 24 is divisible by 12, 24 is also divisible by 8. Now this is your whole hash diagram. What are the maximal elements here? Look at this. Once you know how to draw the hash diagram, the maximal elements are 16 and 24. Both of them are maximal elements, right? Because there is, remember, 16 does not divide 24 or vice versa. So you can't create an edge between both of them. So the maximal elements are both 16 and 24. So if you know what is the concept of a partial order, and if you know how to draw the hash diagram, if you know what is the definition of the maximal element, this is straightforward, right? It's very simple and straightforward, right? So that's why we called it an easy question. But you get some questions like this for 1 mark also in GATE. Okay, let's go to the next question. Again, for those of you who may be confused, n basically means number of elements in this set. Okay, just to be clear. Please read the question very, very carefully, because there is a possibility of a silly mistake here. This is a fill in the blank question. Just wanted to make sure you realize that. Okay, I see a few of you putting in your answers. Okay, let's see. I'll also solve it. I have a slightly different answer, but let's see. Guys, the question does not say which of the 4 options is correct. It says out of the following statements, the number of statements that are true is. So please read this statement. I told you it's very common to make mistakes. Read what you have to fill here. It doesn't say which of these 1, 2, 3, 4 is correct. It says the number of statements that are true from here. So that's why I told you this is very prone to silly mistakes. While it's an easy question, it's typically a 1-mark question, but it's very prone to silly mistakes. Okay, I see a bunch of options, so let's go into it. I have a slightly different answer, so let's go into it, right? This is just about De Morgan's laws, right? It's just applying De Morgan's law on sets. So what does this say? So first let's forget about the number of elements. What is this? A union B complement is nothing but A complement intersection B complement. So this is exactly equal to this. So this whole expression, this is simply De Morgan's law as is. So A union B complement is equal to A complement, and union becomes intersection, then B complement, right? So this is equal to this. So number of elements in this will be equal to number of elements in this. So obviously this is correct. Let's look at the second statement. Okay, so let's see. This statement is correct. Now let's look at the second statement. This says if A intersection B is null set, this is null set, right? Then A complement union B complement. Now how do I get A complement union B complement from this? Look at this. A intersection B is a null set. Okay, you can also write null set like this, right? So let's take complement on both sides. What is a complement of null set? Complement of null set is the universal set. So what is A intersection B complement? It is A complement, or I'll just write A dash union B dash. So then A dash union B dash is the universal set, right? Yes, this is exactly that. So 1 and 2, both of them are correct. Now let's go to the third one. It says if A union B is the universal set, so A union B is the whole universal set, right? Then A dash intersection B dash. How do you get that? Just take complement on both sides. This is nothing but a null set. Now what is the complement of this? A dash intersection B dash. Exactly this term. This is a null set, right? This is equal to a null set. Yes, this is also true. Very simple, right? So first 3 options are true. Now let's go to the fourth option. It says if A is a subset of B, then this is true. But it really doesn't matter. Again, remember that whether A is a subset of B or not doesn't matter, because this is De Morgan's law, right? This is nothing but A intersection B complement is nothing but A complement union B complement. Irrespective of this, this is always true. Okay, this is a tautology. Okay, this is a tautology because this is like the absolute truth by De Morgan's law. So this is also right. So the number of statements which are true is 4. Right? It's such, I mean, that's why I said I have a different answer. Again, if you find that anything is mistaken in any of these questions, please put in a comment, and in case there is a mistake from our side, we'll correct it. Okay, sounds good. So let's go to the next question. Okay. Again, propositional logic is easier than predicate logic, especially in gate. Again, here also there is a possibility of a silly mistake. Please be careful, read the question carefully. Because in the last few years of gate questions, silly mistakes have cost people good ranks. Okay, I see a wide spectrum of answers again, A, B, D. So please check your answers once, just to make sure that you have thought through carefully all the cases. Okay, some of you have put in your answers, and since it's already 8 p.m. I thought I'll explain this because we have 2 more questions that we need to cover, right? So we'll probably finish this by 8:15 or so. Okay, so let's look at this again. We tagged it easy because this is fairly straightforward problem, typically given for 1 or 2 marks. Again, this is propositional logic where it's much easier to solve problems, right? So this is your statement 1, this is your statement 2. Again, you can rewrite this whole statement 1 as not P. Okay, so if those of you who are comfortable with the other notation, you can write it as not P or Q and R. Q and R, sorry, Q and R. Okay, so not P. So let's say it says which of the following options are incorrect, not correct. So if you notice S1, so this is your S1, this is your S2. S1 and S2 are equivalent. They are not, because the not P part is the same, the OR part is the same, but here this is Q double, basically Q implies R and R implies Q. That's what it is. This is not same as Q and R. Again, you can write the truth table and see that this is not same as this, right? So it's very simple to see that S1 and S2 are not equivalent. So this option is certainly not right. Okay, or in other words, this option is incorrect. Okay, so this statement is incorrect. The statement that S1 and S2 are equivalent is incorrect. That's what we need, right? Now what people do is they just say A is the answer and don't go through the other options. There is also all of the above. You have to be careful when you have all of the above. You have to be very careful. Okay, let's look at the second one. It says both S1 and S2s are tautologies, which means they should always be true. Can this always be true? Not necessary. Imagine a case like this. If P is true, not P will be false. So this whole thing will become false. And false, or if Q is false, R could be anything, doesn't matter, because false and anything is false itself. So this whole thing becomes false. So false or false will become false. So I have an assignment of true and false for P, Q and R, wherein I'm getting false. So it's not necessarily always equal to true. So S1 is not a tautology. I don't even have to check for S2. So this statement is also not right. Right? Now look at this. Now since 2 statements are incorrect and it says which of the following options are incorrect, right? This can't be the answer because both of them we know are incorrect. So all of the above is the only option. You don't even have to check option C. But sometimes it is sensible to do it. Again, this also says it's a contradiction. What does that mean? That means this is always equals to false, right? So what does that mean? It says that this is always equals to false. Not necessary. This need not always be equal to false. Again, let me just construct a very simple example where this can be true, right? So you have not P, right? So imagine if P is let's say false, then not of P is true. True or I don't care about anything. True or anything is true. Right, so you have an assignment of values to variables P, Q, R where you're not getting a contradiction, right? So this statement is also incorrect. So you don't even have to check C because if two options are incorrect, all of the above is the only logical option that you have. So D is the option here. That's why we said this is an easy option. If you know how to translate this into not P or Q and R, that's it. That's all you need to. And if you know what does equivalence, tautology, contradiction mean, this is a straightforward question. Okay, let's go into this. This is slightly tricky, so please be careful with the options, please, because there is also none of the above. Again, if it helps you, think in your mother tongue. Again, please be careful here because okay, I see a bunch of answers. I think most of you got it right, thankfully. So let's go into this, right? So it says the statement that we want to translate into predicate logic is no traveler loves the city they live in. That's the statement. Again, the rest of it is given here, right? So if you look at the first statement, what does it say? There exists some x. which means it says, and it says, what if you try to translate this right into English, how do you do it? It says some travelers, because it's talking about there exists X. Okay, some travelers, right, for all cities, like for all Y, city X. So some travelers don't like, so because this is don't they don't love, this is not love, right? Some travelers who live in a city some travelers, and Y is a city, who live in a city Y do not love the city they live in. That's what this is saying. It's talking about some travelers, but this says no traveler loves the city they live in. This is talking about all of them in some sense. This is talking about some travelers only. So most likely this statement is surely incorrect, right? Let's look at this statement. What does this statement say? It says for all X, which means it's talking about all people, but it says not a traveler X, which means this is talking about non-travelers. This is not even talking about travelers, right? So this is also, you can completely eliminate. So you're left with whether C is correct or none of the above is correct. So this is simple to eliminate. Now read this very carefully, because whenever you have none of the above, you have to be very careful. What does it say? For all X, there exists a city Y. Okay, so X is a traveler and there is a city Y where X lives in. Okay, that's what this there exists helps you understand, right? So for all X, there exists Y such that X is a traveler, which means, what does it say? It says X is a traveler, Y is a city, X lives in Y, but X does not love Y. Okay, X does not love Y. This is important. So this, if you think about, if you try to read this in English, this is exactly conveying the same message as this. No traveler loves the city they live in. So that's what the statement here is, right? What is the statement here? If X is a traveler and if X lives in a city Y, and given that Y is also a city, then X does not love Y. That's exactly, if you think about it logically, what this is trying to convey is nothing but no traveler loves the city they live in, right? Or in other words, every traveler does not like the city they live in. Okay, that's the other way of thinking about it, right? And this statement and that statement are exactly the same. So option C, if you translate this into English or any of your mother tongue or any language which you're comfortable in, this fits closest to what you have here, right? So none of the above option can be eliminated. A and B we eliminated based on some simple properties and logic. So if you're careful with these statements, again, some of these questions could even come for 2 marks and they're very easy to score. If you think carefully, you have to be careful, and I'm happy that most of you got it right. Maybe you're thinking in your mother tongue, thankfully, that helps. Okay, cool. Okay, the last question of the day. Again, I see some of our teammates are resolving questions of students related to other topics also. I'm very happy about it. I'm happy that, again, all of us are happy, not just me, but the whole team is happy that some of the miscellaneous questions of students are also getting resolved. In case you have anything, please do reach out to us. Our contact numbers, our emails, they all are available at gate.appliedcourse.com. Okay. I know people will make mistakes. This is a very common problem to make mistakes, and I know people will fall for this trap. Okay, I see 2 answers now. Just think carefully, guys. This is very easy to make a silly mistake in. Again, easy questions are where there are traps for silly mistakes. Okay, let me give you a hint. You have to use Euler's Totient function here. I know it's a vague hint, but think about it. Let's wait for a few more seconds because I think some of you are trying to solve this. So some of you have solved it well. So few more seconds and then we'll jump into the solution. Okay folks, so let's get into the solution. So the question asks us about the number of generators of a cyclic group of order 217. So let's say this is equals to n, right? And what is the number of generators of a cyclic group given the group has order n? It is nothing but it is the number of relative primes. It is the number of relative primes to n, right? And number of relative primes to n is also called as the Euler's Totient function. It is often written like this, right? In most of engineering mathematics and in number theory, this is called as Euler's Totient. I think I got the spelling incorrect. Totient function. Okay, it's called the Euler's Totient function. So to do this, you have to prime factorize 217. So some people, the common mistake, even if you know all these concepts, is people might think 217 is a prime number. It's not, right? 217 is 7 into 31. This is a silly mistake, right? So if this is your n, the prime factorization of 217 is 7 into 31. Now, the Totient function of n, you can easily calculate by using 7 power 1 minus 7 power 0 and 31 power 1 minus 31 power 0. So this gives you 7 minus 1, which is 6. This gives you 31 minus 1, 30. So this gives you 180. So there are, again, Euler's Totient function is a very simple concept which is extremely useful to compute the number of relative primes. Even if you don't know this, you can compute the number of relative primes to n without using this formula also. You can calculate it. It's fairly straightforward if you just apply basic logic, right? So the answer actually is 180 and not 216. I think some of you got 216 because you thought 217 is a prime number. That's the catch. Again, this is how you lose mark. These are some of the silly mistakes. We gave this specific example because we knew people will think 217 looks like a prime number and is a prime number. Okay. Thank you folks. Thank you very much. In the next live session, we'll continue on engineering and discrete mathematics. We'll have a few more sessions for that and we'll make announcements regarding them over the weekend. Okay. By most likely either on Sunday or on Monday about live sessions next week. Okay. Thank you very much. Thank you for participating in this and have a good weekend and please stay safe.